Well, apologies for that, Robin, but I wasn't recording there. Welcome to the show. You're my second ever guest, Dr. Robin Collins from Messiah University in Pennsylvania, if I'm right. You have developed two different fine-tuning arguments for theism. They are focused on two different scientific facts, both of them instances of fine-tuning, but fine-tuning for different things. So it appears that the laws of physics are fine-tuned for life, and it also appears that they are fine-tuned for scientific discoverability. So before we explore that second kind of fine-tuning argument, the newer argument that you've developed, I thought we could look at the more traditional fine-tuning argument, because there's still a lot of philosophical work being done on it. So what is, in a nutshell, the traditional fine-tuning for life argument or theism?
Okay, it starts with the fact that the universe has to be extraordinarily precisely structured for life to exist. And the relevant kind of life here is what I call embodied conscious agents. That is, beings that are embodied, that are conscious, and can interact with each other via what at least they take to be moral concerns. So beings that would be similar to ourselves, but could have much different physical structures. So they could be, hobbits, like in Lord of the Rings, or they could be Jabba the Hutt, as you find in the Star Wars series, right? And so on and so forth, or all the beings you find in the Star Trek series. So any of those would work. And then, okay, from there, that's the facts. And the facts, you can cash them out a little more, is that there's, and the most focus has been on, well, there's the fine-tuning for the mathematical form of the laws of nature. There's a fine-tuning of the initial mass distribution of mass energy at the beginning of the universe. And there's also the fine-tuning for what's called the constants, or a better name for them is the fundamental parameters of physics. These are like the mass of the quarks in the standard model of particle physics, or the strength of the gravitational constant G in Newton's law of gravity that gets taken over into Einstein's theory of gravity. So all those things must be precisely set. And if they were slightly off, a very large possible range, theoretically possible range of values, then there wouldn't be any this kind of life. As an example, a commonly used example is what's called the cosmological constant, or the dark energy density of the universe. If the dark energy density can go in a range of, there's a slight amount of dark energy, but theoretically it could be 10 to the 120th power larger than within the model. But unless it's within a tenfold of what it is, the universe would either expand too rapidly for galaxies to form, and without any galaxies there's no stars, which give you the higher elements that you need for embodied conscious life, or it would collapse back in on itself before such galaxies could form. So there's many other examples, but that's probably the most discussed example in the cosmological literature. So there's the facts about fine-tuning. So sure. From there, you can either take it as a brute fact, there just is this fine-tuning. We're just extraordinarily lucky in these unimaginably precise ways, because 10 to the 120th power is 1 followed by 120 zeros. That's, to have a fine-tuning of one part of that is extraordinarily precise. And that's just one of the many different fundamental parameters that need this kind of fine-tuning. So that's the brute fact hypothesis. Many people feel, that's a last resort to go there. So then there's two other hypotheses. There's one of some sort of theistic hypothesis, an intelligent designer of some sort, or something related to that. that created the universe and then fine-tuned these parameters because that being wanted the existence of intelligent life like ourselves. And then there's the multiverse explanation. And the multiverse explanation says there's a huge, enormous number of universes. Typically, the claim is they're created by some physical process, what I call universe generator. And every time a universe is created, the fundamental like mass energy distribution and the fundamental values of the parameters are set at a different value. Well, given enough of those, I mean, if you have an enormous number of them, eventually one's going to be set just right for life. And then life will develop. And when life develops in that universe into intelligent agents like ourselves develop, then they'll look back and say, wow, aren't we fine-tuned? So you're guaranteed there'll be such intelligent agents developing, and you're guaranteed they're going to find themselves in a life-permitting universe because they couldn't exist anywhere else. So there's no coincidence left to be explained. If you have that multiverse, ignoring maybe the coincidence of having the multiverse, then once you have it, you're going to, with almost 100% probability, get a universe with life. And then there's going to be no coincidence that the beings in that universe find themselves in a life-permitting universe. And that latter claim, that they're guaranteed to find themselves in a life-permitting universe, is called the observer selection effect. And that's going to be important when we look at the discovery and why it bypasses the multiverse objection. I cast that in a Bayesian form in terms of confirmation theory. And I could go into that if you wanted to, in a probabilistic framework.
As we dig into it, it will become more evident that we might need that added complexity. But I think the way you articulated it as kind of broadly an inference to the best explanation is at least a rough and ready way to understand the fine-tuning argument. You have the fact of fine-tuning for life, and then you ask what best explains it. You could appeal to brute contingency or just chance, the kind of there's no deeper explanation, or a multiverse or an intelligent designer. Do you still think that the original fine-tuning argument works, or is your move towards the second kind of fine-tuning argument, which you'll articulate, does that indicate that you think the first one is obsolete?
No, I do think the first one still works. I mean, you just have to accept it runs into certain philosophical problems that the other avoids. So, I mean, when you say works, it works for, who? Because the premises that go into the first fine-tuning argument, those controversial philosophical assumptions, well, some people find them plausible and others don't. And so that's why there's a debate in the literature. So I couldn't really say it doesn't work. It just has problems that the others avoids.
Okay, fair enough. So then that's a good segue into the second kind of fine-tuning. For scientific discoverability, what is that?
Okay, so let me give a little background, what physicists have noticed, and then what I stumbled across. So I had noticed this in the physics literature, is that physicists all the way, going back to Albert Einstein and Eugene Wigner, who was a major founder of quantum mechanics, had noticed that the laws of nature seem to be structured in just the right way. Simplicity, their beauty, these things that we use to guide us to the right theory, or like Paul Dirac said, it's more important that a theory be beautiful than it match experiment. And that criteria of beauty has guided physicists to, served an essential guide actually, to finding the laws governing the fundamental structure of the universe. So it seems much more discoverable than you would expect by chance. And then somebody by the name of Mark Steiner wrote a book on this, The Unreasonable Effectiveness of Mathematics. And he tries to detail that in a very technical way. So that was, I was already aware of that in the late 1990s. So in 2008, I was and then by 2009, I was finishing work on the fine-tuning for life. And as part of that work, I was going through the physics literature and the physics arguments for the fine-tuning for life. And I looked at the fine structure constant, and I want to see what the effects would be of changing it. And when I started calculating it, I realized there was a big effect of it. If we increased it by a fairly small amount relative to its life-permitting range, what seemed to be open wood fires anymore. And open wood or biomass fires were essential to us discovering how to smelt and forge metals, which they think actually happened in the Middle East. And so, these copper nuggets of copper ore were thrown into fires, and then people saw them melt. So that's when you got the Bronze Age, which is based on copper instruments, and then you got the Iron Age. But if you didn't have any of that, if you didn't have the fire, you wouldn't have ever got to that point. We'd just be in a more primitive state. So that was the first case I looked at. And then the idea came to my mind, well, maybe the universe is not only fine-tuned for discovery on the mathematical forms of the laws, but if it was really the discoverability of the universe wasn't just a chance thing, which these physicists had actually suggested it wasn't, then maybe you would expect the fundamental parameters, if you move them around, you would find that it was actually set just right so that we could discover its overall structure. So you saw that happening in the fine structure constant. If we increased it, you wouldn't have had any kind of modern science as we know, and you wouldn't have been able to discover any sort of fundamental physics. You just wouldn't have had it. And then by 2011, I had looked at another parameter called I was looking at a whole bunch of other stuff, but I looked at another parameter called the matter to photon ratio. That's the like a average cubic meter of space, how much matter there is compared to the number of photons of light. And the photons of light, they're particles of light, is dominated by what's called the cosmic microwave background radiation, which is the radiation energy coming from the hot Big Bang. And what I found is that when I first calculated that in the fall of 2011, I thought I'd refuted my thesis because it didn't maximize at the value that it has in our universe. And then yeah, and it was and then I realized in the January 2012 that I'd made a mistake, and I recalculated. And when I recalculated, I got exactly maximized where we were at. I mean, within the margin of the error of the parameters I had to put into this. And so that was really thrilling because this was over a huge range of possible values. It exactly maximized where it is at in our universe. And so I sent this to a cosmology friend of mine in University of Alberta, and he confirmed it. And then I sent it to somebody else, and they confirmed it. So it ultimately got confirmed by like 3 other outside physicists. Yeah, that actually occurred. So that was a really thrilling case. And part of it was it was a direct maximization. And the other thing, it didn't look like it looked like what I was looking for was a discoverability fine-tuning over and above anthropic fine-tuning. So the problem with the case of fire was that it's hard to separate the two, because the existence of fire helps us cook meat, right? And cooking meat helps beings like us either exist or come and evolve or survive. And then, of course, scientific civilization makes it possible for there to be many more beings like this. There's a sort of anthropic effect on life. And so
right. So in that
is a
respect,
hard case to separate.
If maximization for scientific discoverability also entails an increase in the number of observers, then the same kind of anthropic reasoning involved in the multiverse would allow a similar explanation that, in fact, the average observers in a multiverse populate universes that are maximized for discoverability, because it also maximizes observers. That just is what it means to maximize observers. Most observers are in universes like that. So you want to be able to show that maximization for scientific discoverability does not also maximize observers, lest you give way to the same kind of multiverse explanation. Is that a good paraphrase?
Yeah, that's a good paraphrase. There is some ways of trying to get around that, but so I've got a prediction here with this hypothesis. The discovery signaling predicts actual subregions for where the value should be. And one of the predictions was, of course, in the case of biography. And then the predictions have turned out in every single case, all the way through neutrinos. So I have 12 parameters. 12 parameters, it turns out to be the case in. And the total region of parameter space, if you just did a kind of default measure where you use the parameter as the measure of the space, the volume of that subregion compared to the anthropic region is about 1 part in 10 to the 22nd. So it's a really, really small subregion. And so it's virtually impossible to attribute it to chance. So you have it predicts something, you get the prediction. Well, then of course it doesn't run into the problem of old evidence, because it predicts something. A novel prediction turns out to be true. It can be explained by the multiverse hypothesis, because in a multiverse only you've got observer selection effect. But it'd be much more likely if you were just randomly putting these parameters somewhere, it'd be much more likely they'd be in a region, some other region than the small subregion predicted by the discoverability signaling hypothesis. So then we, under the multiverse hypothesis, if that's your only explanation, we should find ourselves in outside that region with overwhelming probability. And of course there'll be some universe in which it's just right, but it's still very unlikely we would find ourselves in such a universe. Just like in a multiverse, there'll be some universe in which you flip a coin 100 times in a row and it's going to come up heads. But, observer does it. But it's very unlikely we, as an observer, would find that happening to ourselves. Okay, so that catches you up to date on the ultimate hypothesis, the discoverability signaling hypothesis.
Yes, it does. I went through the PowerPoint presentation with you about a year ago on that same topic, and going through it now a second time, I think it's finally starting to click. But I will grant that the distinction between fine-tuning for scientific discoverability and fine-tuning for the fact that the laws of physics are fine-tuned for discoverability is a bit abstract, but I think I get it. What I want to zero in on... Oh, go ahead.
Yeah, think of the car analogy. What if you wanted to communicate to the customers that you were, you really cared about quality. And so the customers could recognize that the parameters were in the plausible optimality range. But often it contributes to the experience quality of a car, any kind of instrument, like people that buy guitars or things like that, to know that the person building it really cared about subtle forms of quality that you couldn't have, that aren't immediately evident, that it was really masterly designed. So if you want to communicate, that's the kind of engineers you had. You cared about it. Communicate that to the customers. Given that you are a company of integrity, you think that, they're not lying to you, then you could adjust these parameters so that they were just the fuel to air ratio, so it maximized one of those contributors.
So, but surely in the case of the car being fine-tuned for certain ends, performing well in various ways, to signal that you are a car designer that cares about these features, about crafting a car well, you just make it extra... I barely know how cars work, but you just make it extra fine-tuned for those various ends, fuel efficiency and so on. And it's not a separate kind of fine-tuning you engage in to convey that you care about the car. It's just extra precise fine-tuning. So how is the this fine-tuning for this, what would you call it? This fine-tuning for the fact of fine-tuning. How is that any different in kind than just the original instances of fine-tuning for discoverability?
Well, that's because the different contributors could come into conflict with each other. Like if you maximize fuel economy, you might not minimize pollution. You might have more pollution, so you have to weight things against each other. If all the different contributors maximized in the same place, then of course that was where you'd put it. But it's when you have to make compromises. And so you put it, so what you want to say is you want to say we care about quality, we have expert engineers, and we want to send you the message that we do. And our primary goal is actually to send you that message. So it's in that circumstance you're in which there's potentially the contributors you don't know exactly where all of them, when you sum them all together, maximize, and because of the different weightings. So you need to do something over and above if you want to show that this really can't be accounted for by chance.
Okay.
Does that kind of make sense?
It does on a conceptual level, that the universe is fine-tuned for scientific discovery, and it is also fine-tuned. There's an added layer of fine-tuning in that the laws of physics maximize our ability to discover the fact that the universe is fine-tuned for discovery. So there's two levels to this kind of fine-tuning. So,
in fact, if one of them is in conflict, the message is more important because the discoverability of discoverability is more important. So you want to guarantee it's in the plausible optimality range, but whether it's in the actual optimality range, even there might not even be one because of how there might not be a single weighting of these things. It might be indeterminate. So you want to send that additional signal, then you would do an additional, if you want, you would do an additional fine-tuning to strengthen the signal.
So it's in some ways it's like there's a message etched into the laws of physics in that respect that may well convey something about the intentions of the person or process that brought about fine-tuning.
Well, and you see the logic of it. So there's a logic to sending a signal. And that's all I'm using is the logic of sending a signal. Your sign has to be associated with whatever you're trying to signal, right? That's the first thing. Okay, so it has to be psychologically associated with that. The psychological association or the order of the signs can't be easily attributed to chance. So the more unlikely it is under just chance that you're going to have that psychological association, the more likely you're going to ascribe it to intention. And the third thing is you want it to be recognizable. If it's so hidden that no one recognizes it, the signal is entirely ineffective. So you have to have three everything else being equal criteria. Everything else being equal, the more psychological association, which translates to the more important the contributor. The more important the contributor, the stronger it's going to be associated when you put it at the peak of the contributor to discoverability. Then the narrower the contributor, the narrower the peak that you can calculate within all your uncertainties, the less likely it's going to occur, can be ascribed to chance. And the more recognizable it is, the less likely, or the more recognizable it is, that you would want that, because that's going to increase the effectiveness of the signal, that it actually gets through. Let me give you another analogy that might help. There's another dartboard analogy, and I have, there's this competition for that. If you win it, there's a lot of money associated to it. You're supported for life, and there's few people are born with genes such that they're just outstanding dart players. They're outstanding dart throwers. So you're in this competition. There's 7 dartboards or something like that, and you have to hit these bullseyes. And some of the bullseyes are actually fairly large, so the bullseye itself doesn't necessarily hitting the bullseye. You don't necessarily shine as much as you want to. So each bullseye has a little region in it that's, let's say, is special, and it's that, let's say, colored yellow, red. There's a particular color that's brighter in each of the bullseye. There's a little part of the bullseye that's special. So what you do is not only hit the bullseye, but hit, the little bullseye. You're only required to hit the bullseye, but you hit the bullseye within the bullseye, because that's going to be more impressive to the judges. So as the judges see it, they're going to go, whoa, you that's going to be more impressive. So they're going to think you're a really good dart thrower when they see that, more than if you just hit the bullseye. So likewise, if you're adjusting the parameters, you want to adjust them beyond the plausible optimality region if you can. If there's a sub-region that's like a bullseye within a bullseye, aim the parameter for that.
Okay. That's helping to click it into place. So that the fine-tuning for the fact of fine-tuning for discoverability is like going above and beyond the Call of Duty. It's extra precise fine-tuning, which indicates to us that these features really are fine-tuned for scientific discoverability. It would have been possible to optimize our ability to discover scientific facts about the universe without also making us aware of that fact, that these features,
right, or fully aware. Even before it was sort of indicating that when this makes it much more convincing. And what let me go back just because people need to click this into place. Is there was an article published in the year I think it was 2000 by 2 physicists, AZ and another physicist, and they were asking themselves. It was published in a physics journal. They were asking themselves if a being created the universe and wanted to signal that it was designed, that they created it, how would they do that? And they didn't think of this. They suggested instead that that being would encode a message in the cosmic microwave background radiation, because that would be kind of a universal signal. And then that some people have looked for it a little bit and haven't found any such message. So coming off that, I say, well, there's another way that they didn't think of, and that's using the fundamental parameters to adjust them in the way I said, to send the message. And that would not only send the message that, it was teleologically ordered, but it would also send the message that it was fine-tuned for scientific discovery, kind of do both at once.
So I want to zero in on two potential objections, because you're not just elucidating this fact about fine-tuning for scientific discoverability as an intrinsic find. It's fascinating, but your claim is that it provides evidence for theism, for God's existence.
Well, actually, okay, I presented it that way to you, and I actually do think it does that. But in the book, as I'm writing it, I only claim it is it's designed. It is it's patterned as though somebody were trying to send a signal. And the analogy I use is somebody coming, an alien coming to Earth would say, and we did before the theory of evolution, you would say that organisms are structured in such a way as though they were designed for a purpose. The heart is structured in such a way it's designed for a purpose of pumping blood. Now, so even biologists will speak that way. What's the function of the heart? What's the function of the eye? When, as a matter of fact, there is no the eye is not designed for, to seeing under evolutionary biology. There's no purpose to it. So you can formulate it in a neutral way. And I want to first do that because I want to separate out a hypothesis to explain this from what the pattern is.
Right. But with that fact in place, you do think that theism is the best explanation of this fact.
Yeah. Right.
So do you want to sketch the argument for thinking that, or I can raise those objections? It's up to you. Because that's where I'm interested, is the question of whether theism does anything to explain this over and above chance.
Right. Well, I think you can glimpse a good that is realized by scientific discovery, and particularly knowing that it's discovered. So the knowing that the universe is discovered in this way, I think there's a good you can glimpse. And once you get that there's a good, then that raises the probability under theism above chance. Because under theism, the idea is God is perfectly good, right? So if God is perfectly good, then God's motivation for doing anything is going to be the goodness that it realizes, the value realized. And so I think the only claim here is discoverability, is there's a value to that. And we normally assume that's valuable. Otherwise, scientists shouldn't be objecting too much to that it's valuable to discover the universe. Otherwise, funding in like cosmology and other areas are going to get cut because, right, they claim it's just valuable in and of itself to find out the nature of the universe. And certainly if that's valuable, the whole teleological ordering is going to even be more valuable.
Okay, so just to offer an analogy to break down the logic a bit, mere improbability of some outcome is not enough to rule out chance as a hypothesis, as an explanation.
Oh, no,
right?
Not at all.
So,
all kinds of things
for instance,
very improbable.
Right, so for instance, the exact position of every particle in the universe at this exact moment, that exact position of all the planets and all the stars and all the galaxies and all the particles within those bodies is incredibly improbable. Smaller than 1 part in 10 to the 80.
In classical, physics, it'd be zero probability, but under quantum,
if it's continuous. But right, so it's an incredibly small probability, and yet nobody thinks that there's a design inference here, that therefore God set the present position of all the particles of the universe in place. Similarly, with a coin toss, if you flip a coin 100 times, the exact series of heads, tails, 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 heads, tails, tails is very, very unlikely. But again, given an otherwise random string of heads and tails, you wouldn't infer design, you wouldn't rule out chance. And so most philosophers would say what else is required is that the outcome under consideration is more probable given an alternative plausible hypothesis. And so you've pointed out that scientific discoverability given, say, naturalism or chance is something like 1 part in 10 to the 22nd power. It's a very, very small fraction of a chance. Right. But unless you can show that fine-tuning, those facts are more probable given design, then it just won't matter how unlikely it is given chance.
That's exactly, that's right.
And so that's why it's essential, this second step in the inference to a designer is to show that this outcome is more likely. So I gather that your argument is, if we take theism as a hypothesis, like a full-blooded theism where God is defined as all-powerful, all-knowing, and all-loving, or perfectly good, then it's not that unlikely that he would create a universe fine-tuned for scientific discovery because various goods are thereby realized. Is that the basic
That's
idea?
the idea. It raises it above, I think, significantly above chance because those goods are realized. And this gets into theism. A generic designer won't do, because in a generic designer, why would God, the designer, have that desire versus any other desire? So you have to have something built in that makes a desire to do the good, raises it up, and that's because I think the good is self-motivating. That's how you can get it in theism. Swinburne's basic argument. And so yeah, that's that. And then it's the goodness of God under theism, and you get, that's not arbitrary to ascribe goodness, because anybody that recognizes the good is going to have some motivation to bring it about, because the goodness is self-motivating, a thesis that goes back to Plato. And then second is you can glimpse a good that's realized.
So I guess I want to add pressure to this idea that if we can glimpse goods that are brought about by some course of action, that we can say that it would be not terribly unlikely that God would take that course of action. Neil Manson pressed very vigorously the divine psychology objection when I spoke with him, emphasizing God's omnipotence, that he can do anything that's logically possible. And it would seem with that unfathomable range of creative options, it's very, very difficult to ascribe any particular probability to some concrete outcome like fine-tuning for life or fine-tuning for scientific discoverability, because there just seemed to be an unfathomable range of ways that God could accomplish that end, given that he's omnipotent. I mean, ascribing omnipotence to God in this case doesn't help our probability ascriptions. So how do you zero in on a robust enough probability assignment to fine-tuning for scientific discoverability? Even glimpsing these goods, you would have to say that it's not terribly unlikely that God would choose this particular way of realizing those goods.
Well, in any kind of inference, you have background information, you have evidence. So a lot of our background information is, we have a certain mathematical formula, the laws of physics. We're embodied conscious agents. So throw in a lot about what we already knew before you look at whether they're fine-tuned for scientific discovery. In fact, throw in everything. Throw everything about the everything except, that these values are set for this kind of scientific discovery. Then there's not, if God wants to send that signal, there's not many other options available, because you've already, God can't create a different law structure. That's already fixed in the background. And we always fix, whenever we do an argument, a probabilist, we always fix the background. We have a certain set of background information, and then we focus it on the evidence. So God's omnipotence, no matter how it's, this seems to be the only, or there'd be host of very few. How else would you adjust the constants? How else would you signal this? Especially where it's a kind of signal that God doesn't just kind of, show up in the sky somewhere and big voice say this, which we could easily ascribe to something else besides God, but God embeds it in the fundamental structure of the universe. There's not really a very big range of options. Once we fix all the laws and that there is these parameters, what else do you do?
Well, so I have two reactions to that. And this, again, is the analogous objection that Manson presses in the ordinary fine-tuning for life case, that God can do the miraculous. He's not restricted to what's physically possible. So even if we concretize all of that information in our background knowledge and hold it constant, God still has the option to accomplish these ends through miraculous means, through methods that aren't physically possible. And so why would he be unlikely to pursue
well, maybe not necessarily
those
would
over
be
naturally possible?
But now you don't have this infinite range of possibilities you talked about. You have either miraculous means or non-miraculous means.
It depends on how you divide up the possibility space. I mean,
yeah, well, all these probability arguments depend on that. Some plausible way of dividing up the probability space. But there's also reasons you can give for why. I think it tells us something about God's motivations, and it does tell us something in that God wants us to discover it, wants not to just intervene all the time. Then there's something about human beings making the effort to find this. So once you say and you can kind of glimpse a reason for that, it makes it, we own it more. It makes it more our own. Just like, a parent could intervene to help a student, right, their student, do their homework or something like that. But there's a reason why you want the student to put out their own effort. So you can give, I think, plausible stories of why doing it this way would be a non-interventionist way, would be what I want. And then once you have a non-interventionist, it's through the fundamental structure, and you want to also say, I think part of it, okay, so you want what's so good about discoverability. So I think it's not just pointing to a creator, it's also a good is showing the importance of using reason, rationality. I think that if there wasn't mathematics, there wasn't science, it would have we'd have probably drifted off into superstition real easily, which we are still battling against. I mean, if you're battling against superstition and you're saying, value rationality, value evidence, what you often point to is the success of science. So just those kind of reasons by which you would back the importance of discoverability, I think, give you reasons for thinking God would do it.
I'll give you that. And I think it's becoming clear to me that this line of reasoning, even though it's difficult to say where it goes wrong, feels like it goes wrong somewhere. It feels like skepticism dial turned all the way up, turned unreasonably high up. But still, one concern that bothers me about these arguments for thinking God is not terribly unlikely to do X because X is good. How many good things are there to do? If, for instance, there are 10 to the 22nd mutually exclusive goods that God could
mutually
realize.
Exclusive.
Right. Then in that case, even if you've shown that one of these options is good, you haven't shown that it's likely. In fact, given just a kind of intuitive principle of indifference, the probability that God would take that good in is still just 1 in 10 to the 22. So how do we get a handle on the range of possible goods so as to say that because we've identified one good, like those that result from scientific discoverability, that it's therefore not terribly unlikely that God would bring about that good? Does that worry kind of make sense?
It makes sense, but I think I think the issue is that there isn't this wide class of other equally good possibilities. It's either God signals for discoverability, signals using the parameters or using the fundamental structure of the universe to signal that it's discoverable, or that it was designed or doesn't. So there's only two really big possibilities. You're not splitting up to all the different sets of small possibilities. Like, that's what you would do if you had a case, where you're making decisions between thousands and thousands of different goods that are seemingly equally on par. But the problem is there's not these other goods that are mutually exclusive and equally on par, which is, then you lower the probability, but I don't think you'd have to show that there are. I mean, it's natural to light up that probability space to, it's discoverable or not. And it's that whole class of not that's equally on par with discoverability, because that property of being discoverability kind of stands out. It stands out as kind of has a glow to it among all the other, more detailed properties. Any probability judgment makes, when you have all these different possibilities, any probability judgment over a continuum has to make those kind of assumptions. Like,
it has to
comes
carve
up
up the
just in the
space
standard
somehow.
fine-tuning argument, right, of how you break up the probability space, right? What measure you use. So it's really a question of what measure. So how do you measure the set of class of ways of signaling discoverability to the class of not doing that, the mutually exclusive class that realizes some other good?
I don't know, but I guess it comes down to an issue of the burden of proof. I mean, whose burden is it to provide that information? Is it the objector to the fine-tuning argument in this case, or is it the fine-tuning advocate who has to go the extra mile and show that you can provide a measure in this kind of way? I don't know. I mean, maybe my skepticism is dialed too high.
But I think it is dialed too high. Because you do that with scientific theories. There's always an infinite number of alternative explanations we haven't thought of. That's the classic underdetermination of theory by data problem. So you not only couldn't infer to the truth of the theory, you couldn't even infer to what Bas van Frossen calls its empirical adequacy or reliability, that we could use it as a guide for future experiments. Because how do we know? There's all these other possibilities that we haven't even thought of. So you always, I think, all inferences, all evidence is what goes to what our intuitive way we break up the spaces of possibilities.
Or the possibilities of which we are aware.
The possibilities of which we are aware, not just mere hypothetical. Yeah.
Fair enough. That's a solid response. The other issue I wanted to get your take on is the identification problem, as Manson calls it, or the problem that even if we've inferred to design as the best explanation for fine-tuning for life, for discoverability, for meta-discoverability, it's not clear how then to go to the more specific conclusion that God's existence is the best explanation of that fact, that God is the designer, because there are a number of alternative design hypotheses that are quite different from theism. For any attribute God has, like omnipotence, omniscience, omnibenevolence, we could imagine any series of sub-deities with just less of that property. How do we know that the designer is all-powerful, for example, or all-knowing or all-loving, when it could be any range of quantities of those properties? There are more esoteric hypotheses like the simulation hypothesis, that our particular universe is just the product of a scientist in a mother universe. It's a bizarre explanation, but for the atheist, why is it any less likely than the theistic hypothesis? And so on and so forth. So what would your take on that be, connecting the design inference to theism specifically?
They're all subject to the problem of the leading atheist objection that, like Dawkins raises, the designer would need just as much fine-tuning as the universe itself. So take your higher level universe designer, right? So it's a being in a higher level universe that creates this universe in a test tube. We have, given the fine tuning of this universe, we have every reason to believe that that universe, to have conscious beings, would also require fine tuning, and there'd have to be in addition, even if it was unembodied beings that did this, there'd have to be psychophysical laws connecting their mental states to the physical states. It'd be very complicated laws. So they don't pass what I call the no fine-tuning transfer condition. So, and I think theism does. So in the way I do, I think theism plausibly does. And the way I do it is I look at, theism starts with an idea of a core concept of God. Like for Aquinas, the core concept is God as being of itself. For Anselm, it's the greatest possible being. I like to go with the one that God is, the consciousness, pure, unbounded consciousness. So you start like this. There's something's got to be fundamental. So I would start with the consciousness one. Either something's fundamental, or either consciousness is fundamental, the unconscious is fundamental, or they're both equally fundamental. I think it's at least plausible to think consciousness is fundamental. If consciousness is fundamental, then there's nothing externally constraining the consciousness because it's fundamental. So then you would expect the consciousness is plausible to think in that circumstance it'd be unbounded consciousness. And unbounded consciousness, and consciousness seems to go along with will. I can't imagine a consciousness without a will. And so unbounded consciousness and will, then you get omniscience, omnipotence. Unbounded consciousness is omniscience. Unbounded will is omnipotence, and perfect freedom, because there's nothing constraining it. Not even internally. I'm assuming there's nothing contingent internally constraining. I at least think that's plausible to think that. And then perfect goodness is because the goodness is self-motivating. So that's just Swinburne's argument, that kind of style of argument, that if God's omniscient, God knows what's good. Yeah. And perfect freedom. And the thesis that good is self-motivating. So then there's nothing to fine-tune. There's no parts. There's just this infinite consciousness. There's no parts to make it function. It's pure consciousness with will. So at least plausibly, you could think that you've got an ultimate explanation that doesn't itself involve another sort of fine-tuning. I think all the rest of them, if you look at it, they do. Like the finite subdeity, well then what is restricting its powers? Its powers would have to be like some sort of laws governing its powers, what kind of motions it can move matter and how it can. So it looks like you're going to have psychophysical laws there. The only thing you could do is try to say, well, the subdeity, there's logical constraints we're not aware of that make it, but then it would still be omnipotent. Or there's just pure brute fact contingent constraints, not internal, not external to the deity. And that's a possibility. I think that it would still be a very, very powerful God, obviously, to fine-tune the universe. So I'm not sure practically how much difference it would make. But it's at least plausible, I think, to think that there isn't such contingent constraints. And so all I argue is that theism plausibly does the job.
Well,
and then and then you get cross-religious traditions. You get the idea that Hindu theism, Islamic theism, Judaic theism, and even the Tao, which is not theistic, not personal, but it's all the unboundedness of ultimate reality is there's a common intuition. And then maybe this cosmological argument could be thrown in, and necessity. So I think that you could at least get a plausible rendering. I think that you got to be really careful to not just hypothesize a God that runs into the same fine-tuning, plausibly runs into the same time fine-tuning problem.
Okay, let me give one objection off the top of my head for you to consider. It seems like what you're arguing is that the only plausible ultimate explanation of fine-tuning will be a recognizably theistic omni-god. And there's some plausibility to that.
Or an axiarchic principle. I toyed for a long time with an axiarchic idea.
Sure.
The Leslie's idea. But then I came to the conclusion that the axiarchic principle would have to unify different spatially separated things into one. It's almost like it has a consciousness itself. It can. It's sort of the axiarchic principle in quotation marks would have to be aware of all the different possibilities and aware of how all the parts fit together. So I just think the theistic one makes more sense. I ultimately, after a couple of years, went back to the theistic one.
Fair enough. But so here's my objection, that the atheist or naturalist could just grant you the point that whatever their proffered design explanation is in this case isn't the ultimate explanation, but that's fine. That we always have to admit things that we don't know. So there will be some further explanation of the particular finite designers. And that doesn't make it false. That just means that it's not the ultimate explanation, because it worries me that you could give the same kind of argument for concluding that God designed life and that evolutionary theory is false, right? You could say, well, any posited evolutionary explanation is going to involve mechanisms itself that are fine-tuned, and so in order to arrive at an ultimate explanation that does not itself require fine-tuning or explanation, we have to posit God. But that wouldn't be a good reason to conclude that evolutionary theory is false. It would just be a good reason to conclude that evolutionary theory is not the ultimate explanation of why life exists, because it takes certain things for granted. Similarly, couldn't we just say that the designer may not be the ultimate endgame for reality, but nevertheless the explanation for fine-tuning is the
of this universe? Yeah, I agree. You could say that.
Okay.
I agree. You could say that, but then you would have God ultimately behind it all. So that's fine with me. I mean, a race of robots would have to conclude that it would be some biological life form was their race of androids. It was biological life form was their immediate designer. And so, the universe, maybe it is some other designer. I just don't see, there is here the principle of parsimony does come into play. Right. Why hypothesize that unless there's some explanatory benefit gained by it? And I don't see what explanatory benefit is gained by it.
Okay. Well, I will
but
have
it could
to consider
be the case.
that.
I grant that.
Yeah, I'll have to think about that, and that will help shape my reflections that will go into this paper I'm presenting at the conference, which is on exactly this kind of question. Well, before we wrap up here, because this has been a fascinating conversation and I really appreciate it, Robin, I wanted to ask more broadly about the field of philosophy of religion. One common criticism made of the academic field whenever I tell people what I'm studying and the degree that I got is that philosophy of religion as it's practiced today seems to be more appropriately called philosophy of the Christian religion, rather than philosophy of religion proper. It seems to be very myopically focused on the concerns of the Christian. And more or less, that is my impression. I think if you did a survey, the vast majority of practicing or self-identifying philosophers of religion are Christian. Is that a problem? And if it is, how do we address that? What is your impression?
Well, my impression is it's true, and that might have been good for the beginning. You focus within your own religious tradition. But I have been critical in that way that a lot of philosophers of religion aren't aware, at least have some basic understanding of other religious traditions. I mean, I volunteered years and years ago to teach the Asian philosophy course just for that reason, to gain a basic understanding of other religious traditions like particularly Hindu theism, Buddhism, and Chinese philosophy. I have some knowledge of the Islamic tradition, but once you get into the Islamic tradition and Judaism, you're actually getting closer to the Christian tradition in terms of their overall conception of things. So I do think we really do need to have a broader range of understanding, because I think philosophy, our arguments are ultimately based on our intuitions, right? What we think about what is propositions are likely to be true, because we don't have we can't just test our theories like the scientists can by empirical experiments. And so if we're going to do this, we need to have a broad range of knowledge of other people's ways of thinking. And I would go beyond just the established religions. I would say you should of native peoples, their views of the world, or African. So you should have this broad understanding. You can't be an expert in all those things, but that you should always be aware of that. I mean, in the paper I published, just is published now, I do have a long footnote about Hindu theism. So I think that's true. I agree with the criticism.
I do too. I mean, I think it gets a good point for exactly the reasons that you outline, and it's for that reason. It bothers me just in general. I mean, one thing characteristic about the contemporary era is we have exposure to all kinds of different cultures, and we have vastly more scientific knowledge than we had before. And I think people working in these areas need to have some basic understanding of these sorts of things. Like, I would just give another criticism I have of people that work in metaphysics of material objects. Often I see they work in those fields. I won't name names, but they don't take into account quantum mechanics. They don't have any idea. So they're working all within the classical conception of these objects with parts, and the whole discussion of mereology. But in quantum mechanics, it's hard to make sense of things ultimately having parts, and at least that needs to be acknowledged. And so, it becomes purely hypothetical about a world we don't inhabit.
Right. So you can't be experts in everything, but you need to have a basic understanding, and you can't just bracket that basic fundamental stuff out.
Many of the interesting philosophical questions require an interdisciplinary approach to answer. At least I'm finding, and I think that's right.
And that, is always tricky doing it, because you can get criticism of the people from the other disciplines.
But there's no other way if you want to.
There's no other way of doing it.
There's no other way.
And it's certainly the early days. You could Swinburne and company, Swinburne, Plantinga, you wouldn't necessarily expect it. There's a field before you that needs, plowing that people haven't done. But at this point, it's kind of, I would think it's kind of shameful, if you will. It's not good practice not to do. Now, Keith Ward is a person that really does make this kind of effort. He's kind of been very, I guess he runs the Hindu now, and in retirement's running the Oxford Center of Hinduism or something. So he has a knowledge of world religions, which I think we need to bring to bear. I think it's happening more. Like the book I'm contributing to on design, metaphysics of design, is really Islamic, Jewish. I don't know if there's somebody in Hindu theology, but it's across the board.
That's excellent. I agree with that approach, and that is what I would like to exemplify in my own scholarship and work. So
we could meet again on you had a second set of questions that on the general relations of science and religion.
yeah, I think we found enough to discuss here, and so I would absolutely love to talk to you again, and we can talk about kind of the broad
I have a lot of things to say.
between...
That will help me. That will help me write my chapter. I have a chapter of the book on the philosophical implications. I think it has very big philosophical implications for how we think of the natural world.
Absolutely.
Much beyond just the discoverability.
Yeah, I would love to discuss all of that.
That's what actually what really excites me about the whole project is that more than just as a argument for God's existence.
What it means for how we see the natural world.
What it means for how we see the natural world. What I call the ideals of natural order.
Okay. Well, more to be discussed. So thank you for coming on the channel and having this fascinating conversation with me.
Yeah, it was good talking to you. I hope your work's going well.
Yep, it's going well, and we'll talk soon.
All right, bye, Rose.